Hello everyone, welcome back. We are doing assignment problems. Let's do a quick recap as to what are you going to do when you solve an assignment problem. Question number one, you are going to do something called as a preliminary check. What is a preliminary check? Well, the first thing that you do in a preliminary check is check what the objective of a problem is. You will have two types of objectives. The objective can be a minimization objective or a maximization objective. Minimization objective meaning you want to create an assignment in such a way that all the jobs are done in the most minimum time or cost. Maximization meaning you have to make an assignment in such a way that all the jobs are done in the most maximum allocation, which means it's either profit or sales, anything that you want big returns, big. So if it is a minimization objective, fantastic, because my method, which is the Hungarian method of solving an assignment problem, it does minimize, it does understand, it understands that minimum is good and it starts allocating the minimum. But if it is a maximization objective, my method doesn't understand that. So what you need to do is, I can't change my method, you need to change the outlook of your question. So you change your profit matrix to something called as an opportunity cost or an opportunity lost matrix. How do you do that? You pick up the most maximum profit or the most maximum return or the highest value from the entire matrix. And practically you say that if one person is capable of making this, everybody should be capable of making this. If they are not making it, we find out how many opportunities are they losing. Or pick up the highest value, subtract it from every other value, and what you get is an opportunity lost or an opportunity cost matrix. Now, for solving purposes, you will use the opportunity cost or opportunity lost matrix because assignment problem will give you a minimum opportunity cost or an opportunity lost allocation. Minimum opportunity lost is maximum profit. That is the first preliminary check. Once you do that, you can come to the next step. So step one, objective, if minimization, fantastic. If maximization, change it to opportunity cost and make it minimization. Check number two is a check for balance of the problem. Is your assignment problem a balanced problem or not? What do you mean by balanced problem or not? Is the number of rows and columns equal? If they are equal, fantastic. If not, then you need to add respective number of rows or columns to make it balanced. Once it is balanced, then you can move to the third check, and that is prohibition. What do you mean by prohibition? A prohibition or a prohibited assignment or a restricted assignment is a certain job cannot be done by a certain person. Could be technical difficulties, could be physical or biological difficulties, could be legal difficulties, any difficulties. That job cannot be done by that particular person, or that person cannot do that, cannot work on that machine, or that cricketer can't be sent to bat on that position, and all of that. Whatever it is, you have to understand that that assignment is prohibited. People do it in different ways. Some people put a respectively high number. So in your matrix, if you see a lot of 25, 35, 80, 60, what you do is you put a respectively high number. So put like 1000. What I prefer is just put a dash or put an infinity sign and continue the question, assuming that that cell does not exist. Once this is done, we come to solving the assignment problem, and that has standard steps. Step 1, row reduction. Step 2, column reduction if required. Step 3, assignment. Row reduction, you pick up the lowest from every row, subtract it from every other element. I have explained it to you for one entire hour as to why we do it. Step 2, if every column also has a 0, fantastic. If it doesn't, then we move on to column reduction. Select the least from every column and subtract it from every other column. Step 3 is assignment. What do? You start examining row wise. When you see exactly one 0, assign it. Cancel every other 0 in that column. You keep moving on row wise. If all the zeros are exhausted, fantastic. Exhausted meaning either you've marked it as an assignment or you've cancelled it out. Fantastic. If not, go back column wise, inspecting every column. If there is exactly 1 0 in that column, fantastic. If not, move on to the next column. If there is exactly 1 0, mark it as an assignment. And now because you are going column wise, in that row, if there is any other 0, cancel it out. You keep doing this till all zeros are exhausted and you will have your assignment. In a minimization question, your original question is where I'm going to apply this assignment. In a maximization question, you change the question because you couldn't solve it. Once you get an answer, the answer is again applied in the maximization table. The only difference is that in the minimization, we were getting minimum. In the maximization, we will get maximum, which also I have shown you with proper practical and real examples. Let's come back to questions. I think we stopped somewhere at question number 10. Is that correct? No, we stopped at question number 11. Sorry. So question number 11 we finished, which was the first maximization question. Let's come to question number 12. What does the question say? Solve the following maximization problem. So you want me to solve the maximization problem? Clearly says. So let me do one thing. Let me write down the question. What is the question? Well, the question is A, B, C and D, J1, J2, J3, J4. So 8, 8, 8, 10, 12, 14, 15, 12, 12, 14, 13, 11 and lastly 10, 7, 5, 8. This is it. What do you want me to do? You want me to solve this assignment problem in such a way that the maximum gets allotted. So in my final allocation, I have that allocation where the total is the most maximum. No other assignment will give you a bigger value. Okay. So this is a maximization problem. We come to our preliminary check. Question number 1. What is your objective? Well, my objective is to maximize the assignment. Oh, I can't do it. My assignment or my method or my Hungarian method of assignment only understands minimization objective. Doesn't understand maximization. Well, then change the objective. So step 1 in this case, and I'm writing it here because I don't want to waste too much space. Step 1 in this case, you make sure that you write horizontally, changing objective. What are you doing? You are changing the objective of the given problem. Okay. What do you mean by that? I am changing this. So if you want me to maximize this, can I assume that this is profit of some kind which you want a maximum out of? Okay. So I'm going to say, look at the most maximum profit. What according to you is the most maximum profit? I think I see a 15. There is nothing else apart from a 15 that is greater. So what I want you to do is, I want you to give me an allocation that will maximize the profit. Okay. Then I need to change the objective of the question first and change it to minimization by saying that if J3 on B can give me a profit of 15, everybody is capable of giving me a profit of 15. If I'm not getting a profit of 15, I need to check how many opportunities are we losing or how many opportunities is it costing me. 8, 15. 15 minus 8 is 7 opportunity lost, 7 opportunity lost, 7 opportunity lost, 10, 15, 5 opportunities lost. 12, 15, 3, 15, 14, 1, 15, 15, 0, 12, 15, 3, 15, 12, 3, 15, 14, 1, 15, 13, 2, 15, 11, 4. 15, 10, 5, 15, 7, 8, 15, 5, 10 and 15, 8, 7. What is this? You have changed a maximization objective to an opportunity lost or an opportunity cost objective. So step 1, changing objective is done. Now some people also, see now your module, when I come to the institute questions, I will show you the solution that the institute has. They don't write too much. I prefer writing a lot. I prefer telling and especially when such questions are asked to you for like 7 marks and 8 marks. So I will give you the mathematics later. I will right now roughly tell you that, or I'll tell you now only, later also when I'm discussing the paper I'll tell you. See, your paper is a total of 100 marks and you get 3 hours for it, correct? 3 hours is, sorry, 6 3s are 18, 180 minutes. 180 minutes divided over 100 marks is 1.8 minutes per mark. Obviously I teach mathematics, so I love doing all of this. So if I ask you a question or this question for 8 marks, you have 14 minutes for that question. If this same question is even asked for 6 marks, you still have 10.8, which is roughly 11, but let me keep it lower end. You have 10 minutes for this question. So if you have 10 minutes, why not decorate it as much as you can and write it down? Because see, you are also going to have MCQs. Now that MCQ is for 2 marks. Technically 2 marks with 1.5 minute per mark is 18 2s are 36. So 3.6 minutes. You don't need 3.6 minutes for an MCQ. So you are going to end up having a lot of time on you. So my point is, why not decorate it as much as you can so that the person checking the paper also understands that you've understood each and every step, and God forbid you have somewhere in between made a silly mistake and screwed up your final answer. At least the person is happy that, oh, it's written very well. Let me give this person some marks for at least knowing what is supposed to be done. So step 1, changing objective. I have changed the objective. Question number 2, is there an imbalance or is this problem unbalanced? No, there are 4 columns and 4 rows. So perfect. Or rather 4 jobs and 4 people can do these jobs. Question is perfectly balanced. Then comes the last question, which is question number 3. Is there a prohibition? Well, I have just put out matrix of values. I haven't given any verbal along with it. In your institute material, there will be verbally written questions. So we will go back and check whether verbally they are asking for any prohibition. Are they saying due to physical disabilities, J3 cannot work on machine D? Are they saying anything like that? We will go and check. Right now, no prohibition. Fantastic. We can go ahead to solve the given problem. Step 2 is row reduction. Pick out the smallest from every row and subtract it from that row. What is the least? 3. 7 minus 3 is 4. 3 minus 3 is 0. 3 minus 3 is 0. 5 minus 3 is 2. 7 minus 1 is 6. 0, 0. 8 minus 1 is 7. There is a 0 already. No need of reduction. 7, 0, 2, 10. And the least is 3. So 2, 0, 1, 4. Check if every column also has a 0. Where the first column itself doesn't have a 0. Well, then I have to do column reduction. So I come to step 3. And that is column reduction. A, B, C, D, J1, J2, J3, J4. What is the least in this column? 2, subtracted from everywhere. So it is 4 minus 2, which is 2, 6 minus 2, 4, 7 minus 2, 5, 2 minus 2, 0. 0, 0, 0, 0, 0, 0, 2, 1, 2. So 0, 5, 8, 2. Step 1 row reduction, step 1 changing objective, step 2 row reduction, step 3 column reduction, done. Step 4 assignment. Let's start assigning. A, B, C, D, J1, J2, J3, J4. 2, 4, 5, 0, 0, 0, 0, 0, 0, 0, 2, 1, 0, 5, 8, 2. Assignment with a pencil so that if any corrections are required, I can quickly do them. If you do assignment with a pen and midway you realize somewhere that, oh, I shouldn't have done this, I've kind of made a mistake, there's no going back from there then. You'll have to draw the entire matrix again and then do it again. So I suggest that assignment always with a pencil. So if you make a mistake, quickly erase and undo it. Row wise. Once you've done it and you know you're confident about the answer, if you want, then repeat it with a pen. Like erase everything and then do it with a pen, no problem. But try and keep the assignment with a pencil. 3 zeros, I'm not allowed to touch 3 zeros. 1 0, then only I'm allowed to touch. Forget it then. 2 zeros, I can't do anything. Okay. 1 0, perfect, fantastic. Mark it as an assignment. Now, if I have marked this as an assignment, which is J3 going to B, then B can't go to anybody else. Then cancel every other 0 in that column. J4, there were 2 zeros, but one is cancelled, which means only one remains. Take it. In that column, cancel every other 0. There is nothing else to cancel. You are done row wise. Let's do this column wise. Column number 1, 1 0 already marked. 4 zeros already marked or cancelled. 2 zeros can't touch. 1 0, fantastic. Mark it as an assignment. In that row, cancel every other 0. I'm done column wise. Let's start doing this row wise. Already marked or cancelled. 2 zeros, one is cancelled. Then one is left. Mark it as an assignment. Cancel everything in that column. Done. This is it. And a very beautiful assignment diagonally. So just for you, I'm quickly going to repeat this. Let's start row wise. 3 zeros cannot touch, not allowed to touch. 2 zeros cannot do anything. 1 0, mark it as an assignment. If there is other 0 in that column, cancel it out. 1 0. 1 0. Mark it as an assignment. Cancel everything in that column. Row wise done. Let's go column wise. Done, done. 2 zeros can't do anything. 1 0. Mark it as an assignment. Cancel every other 0 in that row. Again start row wise. Done. 1 0. Mark it as an assignment. Done? Yes. That's your answer. Your answer is J1, J2, J3, J4. D, C, B, A. So, J1, J2, J3, J4, D, C, B, A. Now, when you are writing down the final answer, you will go back to the original because this was what I was asked to maximize. I changed it and I minimized this because I know minimum here means maximum here. So, J1 on D is 10, J2 on C is 14, J3 on B is 15 and J4 on A is 10 for a maximum of 10, 10 which is 20, 20 and this will be close to 30 but one less, so 29, 29, 49 if I am correct. Let me check once again. 10, 10, 15, 14 is a total of 49 for a maximum of 49. That's it. That was your answer. Let's move on to the next question. This is question number 12. Let's come to question number 13. Solve the maximization problem. Again, they want you to maximize this. So it is 1, 2, 3, 4, 5, J1, J2, J3, J4. So let me do a thing. Let me write down the question. '86, 55, 72, 86 again, and again 72. 86, 55, 72, 86, 72. 78, 79, 65, 70, 70, 62, 65, 63. Oh, this is going to be tiring. 65 and 71, and lastly 81, 60, 80, 71 and 80. Done? And it says solve the following maximization problem. So you want me to maximize this, not minimize. They are not asking you to minimize, they are asking you to maximize. Well, if they are asking you to maximize, and we've learned that assignment problem cannot maximize, assignment problem can only minimize, then step 1 in this is always going to be the preliminary check, or the 3 preliminary checks. Preliminary check number 1, what is the objective? Maximization. Sorry, can't do. You will have to change the objective, and then and only then can I solve it. Okay, so I am going to say step 1, changing objective. So J1, J2, J3, J4, 1, 2, 3, 4, 5. What are you going to do? Pick up the most maximum out of the entire matrix and subtract it from every other element. Correct? So, what is the most maximum out of the entire matrix? So, when you look at the entire matrix, the most maximum in the entire matrix is, if I am correct, 86. I don't see anything bigger than 86. So we start subtracting. 86 minus 86, 0. Vertically, horizontal. Let's go vertically. 86 minus 55 will be 1 extra. So 31, if I am correct. 72 and 86, so I think 12, there is definitely a 12 there, and no, there won't be a 12, there will be a double, so 4, so I think 14, 86, 86, 0, 86, 72, 14. 86, 78 is going to be 2 here and 6 there, so I think 8, 79, 86 is going to be 1 and another 6, so 7. 60, 86, 65 will be 65, 75, 85 and then another 1. So I think 21. 86, 70 is going to be 16 if I am correct. 16. 86, 62 is going to be 8 here and then another 10 and then another 6. So 24 if I am correct. 86, you can do it in the calculator also, there's no hard and fast. 86, 65, this is 24, this is another 3 more, so that should be somewhere around 3 less in the difference. 21, 86, 63, that will be 1 less from this, so 23. 65 will be 21 and 71 will be 86, 71 will be 15 if I'm correct, yes. 86, 81 is 5. 8660 is going to be 70, 80, 26. 8680 is going to be 6. 8650, 71 is going to be 15. And 8680 is going to be 26. Correct? So, changing of objective is done. Perfect. The next step that we move into is preliminary check number 1. Is the problem balanced? Well, yes. No, sorry. Is the objective minimization? No. The objective was maximization. So I changed it to minimization now. Then now we come to question number 2 and that is the problem balanced? Well, no, the problem is not balanced. How come? Well, there are 4 columns while there are 5 rows. I am 1 row short. Then I will go on to step 2, and that is balancing the problem. So, J1, J2, J3, J4, J5, which is a dummy. So the rest as and how it is, just an extra column. 1, 2, 3, 4, 5. 0, 31, 14, 0, 14. 8, 7, 21, 16, 16. 24, 21, 23, 21, 15. 5, 26, 6, 15, 26. And lastly 0, 0, 0, 0 and 0. So the objective was maximization, we changed it to minimization. The problem was not balanced, so we balanced it by adding a dummy column. Question number 3, is there a prohibition? Well, there's nothing mentioned and I haven't added a prohibition by putting a dash anywhere per se. So can I say then the preliminary check is done? If the preliminary check is done, move on to solving the problem, and that is step 3, and that is going to be step 3 of this problem is going to be row reduction. So J1, J2, J3, J4, J5, 1, 2, 3, 4 and 5. Oh, but sir, every row already has a 0. If every row already has a 0, then we are not going to do row reduction. So what am I going to do? I am going to say, since every row, let me write it here, since every row has a 0, row reduction is not required. Okay, then step 3 is going to be not row reduction, column reduction. So let me write that here, and that is step 3, column reduction. So J1, J2, J3, J4, J5, 1, 2, 3, 4, 5. Let's start with column reduction. Does both fit together? Yes, perfect. So in this column, if you notice, there are already 2 zeros. Then it doesn't require column reduction. So 0, 31, 14, 0, 14. 0, 31, 14, 0, 14. This column does not have a 0, requires reduction. You are going to reduce it by 7. So it is going to be 8 minus 7. 8 minus 7 is going to be obviously 1. Is that right? So 1. Then you have 7 minus 7, which is 0. Then you have 21 minus 7. 21 minus 7 will be 3, but 1 extra, so 4. 14 if I am correct. Then you will have a 16 minus 7, which should be 9 and 9. Let's come to this column. The least is 15. So I will subtract every one by 15. 24 minus 15 is 9. 21 minus 15 is 6. 23 minus 15 is 8. 21 minus 15 is 6. And 15 minus 15 is 0. Let's come to the next column. 5. 5 minus 5 is 0. 26 minus 5 is 21. 6 minus 5 is 1. 15 minus 5 is 10. And lastly, 26 minus 5 is 21. We come to the last column. Well, it is already full of zeros, so I don't need to worry there. 0, 0, 0, 0 and 0. Step 1 row reduction. Step 2 column reduction. And now we come on to step 3. And that is assignment. The only difference here is step 1 was changing objective. Step 2 was balancing the problem. Step 3 was supposed to be row reduction, but it already has a 0 in every row, not required. So we moved on to step 3, which is column reduction. And now we go to step 4, and that is assignment. J1, J2, J3, J4, J5, 1, 2, 3, 4 and 5. Write down the matrix as and how it is. 0, 31, 14, 0, 14, 1, 0, 14, 9, 9, 9, 6, 8, 6, 0, 0, 21, 1, 10, 21, 0, 0, 0, 0 and 0. Let's start the assignment. Row wise. 1, 2, 3. 3 zeros. Cannot do anything about it. Move on to the next. 2 zeros. With 2 zeros, I cannot do anything. Move on to the next. Entire row. 1 and only 1 0. Fantastic. Mark it as an assignment. Cancel every other 0 in that column. Let's move on to the next row. So, sorry, I think I cancelled everything. Just give me 1 second. First row 3 zeros cannot do anything. Second row 2 zeros cannot do anything. Third row exactly 1 0. Mark it as an assignment. Cancel every other 0 in that column. Next row 2 zeros, but one is cancelled out already. So 1 0. Mark it as an assignment. Cancel every other 0 in that column. Let's come to the last row. 2 zeros, one is already cancelled. So 1 0 left. Mark it as an assignment. Cancel every 0 in that column. No 0, so it's okay. Let's start doing this column wise. Already marked or cancelled? Exactly 1 0. Mark it as an assignment. Cancel every 0 in that row. No 0, or there is 1 but already cancelled. Move to the next column. 1 0 already marked. Well, exactly 1 0. Fantastic. Mark it as an assignment. Cancel every 0 in that row. And lastly, all zeros are already marked or cancelled. Have I exhausted all the zeros? Yes. So if all the zeros are exhausted, which means my assignment is done. So 1 goes to J4, 2 goes to J2, 3 goes to J5, 4 goes to J1 and 5 goes to J3. What I'm going to do is, before I write down the final answer, I'm going to do this once again for you, the assignment bit, so that just in case anybody still has a problem or has a doubt, I can quickly clear that off right now. So, first row 3 zeros, cannot do anything. Second row 2 zeros, cannot do anything. Third row 1 0, okay, mark it as an assignment. In that column, cancel all other zeros. Fourth row 2 zeros, but 1 is cancelled, so only 1 left. Mark it as an assignment. In that column, cancel everything out. Fifth row, exactly 1 0, already cancelled. Let's start column wise. Already marked and cancelled. Exactly 1 0. Mark it as an assignment. Cancel every 0 in that row. Exactly 1 0. Mark it as an assignment. Cancel every 0 in that row. Exactly 1 0. Mark it as an assignment. Cancel every 0 in that row. Done. So the answer to this is 1, 2, 3, 4, 5. J1, J2, J3, J4, J5. Oh, sorry. Losing it. So 1, 2, 3, 4, 5. 1 goes to J4. 2 goes to J2. 3 goes to J5. 4 goes to J1. And 5 goes to J3. Now frankly, it is not really required to write down who goes to the dummy. All I remember is that 3 will not be doing any job. I don't really need to write it, but that's okay. J3 going to J5, put a dash there. Let's write down the profits for the rest. So 1 going to J4 is 81. Okay then. Then I have 2 going to J2. 2 going to J2 is 79. Then I have 3 going to J5. No need to write it. 4 going to J1. 4 going to J1 is 86. And lastly 5 going to J3 is 71. For a maximum of 81, 79, 86, 71. So the answer is 370. And this is how you solve an assignment problem. Preliminary check and then row reduction, column reduction, assignment. This is going to be your final answer. Now before I move on to the next question, I want to clarify one doubt which a lot of students have or they end up asking, especially in class. Sir, is it important to change the objective first and then balance? Can we balance first and change the objective? Yes. But remember one thing, when you balance first, you know what you're going to do? You will add a column here itself and write down 0, 0, 0, 0. After this, you will change objective. Am I correct? So when you change objective after this 86 will be there with a 0, 0, 0, 0 because you balanced it first. And when you subtract everyone by 86, here in the last column that you had 0, 0, 0, 0, you are now going to have 86, 86, 86, 86. Will that change the answer? No. But what happens is, it becomes a rather extra calculation for no reason. Like that 86, 86 doesn't really matter to me in any way. But I have to now keep subtracting. And that is why what I prefer is that you first change the objective and then add the dummy row or a column with 0, 0, 0, 0. Although if you balance first and then change objective, doesn't really matter. You might have to do extra calculations, but the final answer will remain the same. That is question number 13. This is the final assignment with a maximum of 370. Let's move on to question number 14. We come back to question number 14. That was question number 13 that we did. Question number 14. What does question number 14 say? Solve the minimization problem, which means I have to minimize. Fantastic. So to solve a minimization objective problem, let's first write down the question. So 1, 2, 3, 4, 5 and A, B, C, D, E. 6, 3, 3, 6, 4, 12, 1, 6, 9, 0, 3, 6, 5, 2, 2, 11, 0, 2, 13, 1 and lastly 15, 9, 6, 11 and 5. 6, 3, 3, 6, 4, 12, 1, 6, 9, 0, perfect. 3, 6, 5, 2, 2, 3, 6, 5, 2, 2, 11, 0, 2, 13, 1, 11, 0, 2, 13, 1 and 15, 9, 6, 11, 5. Fine. That is the question that we are going to do. Question number 1. So the preliminary check. Question number 1. What is the objective? Minimization. Fantastic. Question number 2. Is the problem balanced? Yes. There are 5 columns and 5 rows. So 5 rows, 5 columns. Balanced. It's an n cross n matrix. Question number 3 and the last question. Is there a prohibition? Well, not that it's mentioned here. Fine. Then we begin with step 1 and that is row reduction. So step 1, which is row reduction. Okay, let's start the row reduction. 1, 2, 3, 4, 5. A, B, C, D, E. Pick up the smallest from every row, subtract it throughout the row. In this row, the smallest is 3. So subtract 6 minus 3 is going to be 3. So 6 minus 3 is going to be 3. 12 minus 3 is 9. 3 minus 3 is 0. 11 minus 3 is 8 if I am correct. 8, 9, 10, 11. Perfect. 15 minus 3 is 12. Let's go to the next row. Now the next row already has a 0. So if the next row already has a 0, reduction is not required. 3, 1, 6, 0, 9. Let's go to the next row. Well, in the next row, the least is 2. Subtract throughout by 2. 1, 4, 3, 0, 4. The next row has a 2. Subtract throughout by 2. 4, 7, 0, 11, 9. And the last row already has a 0. No reduction required. 4, 0, 2, 1, 5. Row reduction done. Step 1, step 2, column reduction if required. Well, is there column reduction required? Well, yes it is. How do you know? Well, I know for a fact because the first column itself does not have a 0. Fine then. Step 2, column reduction. So 1, 2, 3, 4, 5. A, B, C, D, E. Let's start column reducing. The least in the first column is 1. Subtract throughout. 3 minus 1 is 2. 2, 0, 3, 3. The least in this column is 1 again. So 8, 0, 3, 6. Oh, sorry. There was already a 0. Reduction was not required. So this is 9. I'm sorry. 1, 4, 7, 0. 9, 1, 4, 7, 0. I'm sorry about that. Already has a 0. So no reduction required. 0, 6, 3, 0, 2. Already has a 0. So no reduction required. 8, 0, 0, 11, 1. Does not have a 0. The least is 4. Subtract. 12 minus 4 is 8. 9 minus 4 is 5. 4 minus 4 is 0. Again 9 minus 4 is 5 and 5 minus 4 is 1. Step 1, row reduction. Step 2, column reduction. Step 3, assignment. So, for assignment, we write down the matrix as and how it is. So 1, 2, 3, 4, 5, A, B, C, D, E. Let's start writing it down. 2, 2, 0, 3, 3, 9, 1, 4, 7, 0, 0, 6, 3, 0, 2, 8, 0, 0, 11, 1, and lastly 8, 5, 0, 0, 5, 1. Let's begin the assignment. Row wise. Let me draw a line here so that there isn't any confusion. Row wise. Exactly 1, 0. Fantastic. Mark it as an assignment. Cancel all zeros in that column. Row wise. Exactly 1, 0. Fantastic. Mark it as an assignment. Cancel every other zero in that column. Row wise 2 zeros. Can't do anything. Row wise 1, 0 already cancelled. Row wise 1, 0. Mark it as an assignment. Cancel everything in that column. I'm done row wise. Let's start column wise. Column wise exactly 1, 0. Mark it as an assignment. Cancel every zero in that row. All zeros are marked or cancelled. Fantastic. I'll quickly show this to you one more time so that we can continue writing the final answer. Row wise exactly 1, 0. Mark it as an assignment. In that column, cancel every other zero. Row wise, mark it as an assignment because exactly 1, 0. Cancel every other zero in that column. Row wise, 2 zeros, I can't do anything. So I leave them alone, I move on. Row wise, cancelled already. Row wise, exactly 1, 0. Mark it as an assignment. Cancel every zero in that column. Let's go column wise. Column wise exactly 1, 0. Mark it as an assignment. Cancel every other zero in that row. Done? Fine. Let's start writing the answer. I'm writing it here only so that it's easier to refer. 1, 2, 3, 4, 5. 1 goes to C, correct? 2 goes to D, correct? 3 goes to A, perfect. 4 goes to 4 has no assignment. Okay, let me do one thing. Let me see if I've made a mistake anywhere. I've already done this twice, but still, let me be doubly sure that row wise exactly 1, 0. Mark it as an assignment. Cancel every zero in that column. Row wise exactly 1, 0. Mark it as an assignment. Cancel every zero in that column. 2 zeros, I can't do anything. 1, 0 already cancelled. Row wise 1, 0. Mark it as an assignment. Cancel every zero in that column. Okay. Column wise. Column wise exactly 1, 0. Mark it as an assignment. Cancel every other zero in that row. Oh God. Am I making a mistake somewhere? 1 goes to C, okay. 2 goes to D, okay. 3 goes to A. 4 still doesn't have an allocation. 5 goes to B. So the only one left is 4. If the only one left is 4, who is left? A is done, B is done, C is done, D is done. So only E is left, no? Why don't you assign E to 4? Is that okay? And this, my dear friends, is from where assignment problem begins. What we were doing up till now, nothing, not that it's wrong, but I had taken questions or I had planned questions where you will always get assignments. So what was happening up till now is, if you had 5 rows and 5 columns, you had 1, 2, 3, 4, 5 assignments. Perfect. If you had 4 rows and 4 columns, you had 1, 2, 3, 4 assignments. I have always taken questions where you were lucky, where everywhere you always got an assignment. You have 5 columns and 5 rows, but you have only and only 1, 2, 3, 4 assignments. This 5th one I made. But sir, why isn't it allowed? Why? Now that's the only one left. No, might as well give it away. Not allowed. And listen to what I'm saying carefully. The total cost of assignment should be 0. Arey? How come it's 0? We applied it through the original table. No, I agree. But remember the first question where I very slyly applied into this question in this table itself, and I showed you 0 plus 0 plus 0 plus 0 plus 0 is 0. And that is what I'm talking about. The total assignment should always be 0. If I assign 4 to E, doesn't that give a 5 in between? And doesn't the total assignment become 5 and not 0? Then this is not an optimal assignment. It is an assignment. You can do it and start the work. But if you apply this assignment, I don't guarantee you that this is the best. There could be a better assignment available which you are not using. And like I said, this is from where an assignment problem begins. So if you understand whatever I'm going to do after this, and this is the last impediment, assignment problems is done. Then no matter what assignment problem anybody throws at you, you can always solve it. I'm going to repeat. Step 1, the problem was minimization, so no need of change of objective. Step 1, row reduction. Step 2, column reduction. Step 3, assignment. When I assigned, I realized that I had 5 rows and 5 columns, but I only got 4 assignments. Then I haven't reached an optimal assignment, or I haven't reached the best assignment. I reached the best assignment if and only if I have 5 rows and 5 columns. I have to have 5 assignments. 4 rows, 4 columns, 4 assignments. 6 rows, 6 columns, 6 assignments, which was always happening up till now. Because up until now, I always took questions that would always give you a final answer in the assignment. But now we come to questions where you don't get an optimal assignment. And this is from where a real assignment problem will start. So this is what I want you to do. Before I continue after this, which I'm going to do a quick recap of what we do and then continue, I would want you to pause the video, wash your face, take a break, have a cup of tea or coffee, take a walk and come back. And then continue, because I want your 100% and undivided attention from here. Because up until whatever we've done is a cakewalk. Doing that is not a problem. But it is not always that your question will be that easy. And your module definitely doesn't have that easy questions. Your module has questions that start at a different level. So if you want to be able to do those questions, you need to understand the next part that I'm going to do. And like always, it's just once that I'm going to explain it in complete detail. Later, I'm only and only going to directly apply whatever we do. I'm not going to explain why and where it comes from. So this is where you pause the video and come back. If you are fresh enough, you want to continue, go ahead. What is an assignment problem? You have to assign a certain number of jobs to a certain number of people on a one-to-one basis. One person does one and only one job. How do we do that? We do that using a method called the Hungarian method. I will run you through the script of everything. Right now, just humor me and play along. How do you do it? Well, you do a preliminary check in which the first thing that you check in the preliminary check is what is the objective of the problem. If the objective of the problem is to minimize, fantastic, because my method can. If it is to maximize, change it and make it minimization. Okay, what is the next? The next is check if the problem is balanced. The number of rows and number of columns should be equal. If not, make a change there. And question number 3, and the last question, is there a prohibition of sorts, or is there a prohibition of any kind? Well, there is a prohibition, then add it and put a dash there or an infinity sign, and then move on to solve the question. Once you begin to solve the question, step 1, row reduction, select the least from every row, subtract it from that row. Step 2, column reduction. If required, if every column doesn't have a 0, select the least from that column, subtract it from every element of that column. And step 3, assignment. When you assign, in the final answer of your assignment, the number of assignments that you get should be equal to the number of rows and the number of columns. Here, if you notice, I got only 4 assignments. I was supposed to get, or I should have gotten 5 assignments. If I have gotten 4 assignments, is this an optimal assignment? No. Optimal assignment is not reached. If optimal assignment is not reached, what we are going to do now is, we are going to change this matrix so that we get an answer or we achieve an optimal assignment. I repeat, what are we going to do? We are going to change this matrix and then make an assignment such that the assignment that we get is an optimal assignment, or in other words, I get 5 assignments. Because if I don't get 5 assignments, it is not an optimal assignment. And this is going to be the real task, and I want you to pay attention and listen to whatever we are going to do here. How are you going to change this assignment? Well, to change this assignment, I am going to draw lines. What? I'm going to draw lines. But for what? What I'm going to do is, I'm going to change this matrix, but bearing in mind that these zeros should not get altered, because 0 meaning the best, and if I change the 0, which means I'm changing the best. So I will try to change the matrix without changing these zeros. How am I going to do that? I am going to draw lines. What do you mean by drawing lines? Well, what I mean by drawing lines is, I am going to draw vertical and horizontal lines on this, vertical and horizontal lines on this to cover up all the zeros that are important to me. So what, you're going to draw 1, 2, 3, 4, 5 lines, that's it? No. I am going to cover these lines with minimum number of lines. Like if I draw 1, 2, 3, 4, 5 lines, all the zeros are covered, but then everything is covered. That's not serving a purpose. I should cover these zeros in as few lines as possible. Like once I do this, you will understand this much better. But just for the heck of it right now, let me give you an example. So suppose, no blank pages, fine, I found one. Suppose there is a matrix and that is A, B, C and 1, 2, 3. Correct. And suppose there is a 2 here, there is a 4 here, 0, 5, 6, 0, 0, 0, 0. And let's say when I started assigning, this got assigned, so all this got cancelled, then none, none. Then when I'm going column wise, this got assigned, all this got cancelled. Do you notice that I should have had 3 assignments because I have 3 rows and 3 columns, but I only got 2 assignments. This is one and this is the other, which means I didn't get the best assignment. So now I have to redesign this matrix, but without changing the original zeros. So I will have to draw vertical and horizontal lines to cover up the zeros. Yes. So why not just draw 1, 2, 3 straight lines, finish it off. And then everything will get covered. I should do this in as few lines as possible. What do you mean by few lines? See, if I draw one line like this and one line like this, in just 2 lines, aren't all the zeros covered under the line? Perfect. In just 2 lines, all the zeros are covered. And that is exactly what I want to achieve. There are different ways of doing this. Now, because this is just a 3 by 3 matrix, it was easy. When it's a slightly bigger matrix, it becomes a little tedious to do. And that is why I want you to pay attention. So, step 1 row reduction, step 2 column reduction, step 3 assignment. Since number of assignments is not equal to the number of rows and columns, optimal assignment is not reached. We redesign the reduced matrix by drawing lines. Okay, so to draw lines, first let me write down, because again I don't want to draw lines in this only, I don't want to dirty this. You can. So see, some people in the column reduced matrix only they assign, and in that only they start drawing lines. I don't want to do that. That is why I am going to draw a new matrix here. So 1, 2, 3, 4 and 5, and I have A, B, C, D, E. So 2, 2, 0, 3, 3, 9, 1, 4, 7, 0, 0, 6, 3, 0, 2, 8, 0, 0, 11, 1, 8, 5, 0, 5, 1. So just for the heck of it, let's just assign once again. Row wise 1, 0, mark it as an assignment, cancel every 0 in that column. Row wise 1, 0, mark it as an assignment, cancel every 0 in that column. 2 zeros can't do anything, done. 1, 0, mark it as an assignment, cancel every 0 in that column. Let's go column wise. 1, 0, mark it as an assignment, cancel every 0 in that row. I got only 4 assignments where I should have gotten 5 assignments. So optimal assignment is not reached. If optimal assignment is not reached, we have to redesign this given matrix. How do you redesign the given matrix? By drawing minimum number of lines first and covering the zeros. Humor me, whatever I'm doing, humor me, go along with me. It's a process. Operational research is a process and you have to keep following the process. How do you draw the minimum number of lines? There is a process, and the process is step 1. Step 1. Mark a row that does not have an assignment. Mark a row that does not have an assignment. Tick mark a row that does not have an assignment. Any row that does not have an assignment, mark it. Okay. So let me do one thing. Instead of writing it here, let's write it on a fresh page because we are going to use this over and over again. So if you have it on a fresh page, we can keep referring to it. Here, then I will have to, if I lose this page, it will become a problem. So let's do this on a fresh page. What are we doing? We are learning how to draw lines, or we are learning drawing lines. Number 1. Mark a row that does not have an assignment. So mark a row or figure out that row that does not have an assignment. Obviously, there will be a row that does not have an assignment. Well, we are doing this because we didn't get an assignment in every row. If we would have gotten an assignment in every row, we wouldn't have to do this. So mark a row that does not have an assignment. Step number 2. Step number 2 says, in the marked row, very important, in the row that you just marked a row that does not have an assignment, no? In the marked row, mark, what do you mean by mark? Tick mark. A column that has a 0. What do you mean by 0? This is what I mean by a 0. Mark a row that does not have an assignment. In the marked row, mark a column that has a 0. Okay? Step 3. In the marked column, you just marked a column. In the marked row, mark a column that has a 0. So now in the marked column, mark a row that has an assignment. I know this will feel a little cumbersome, this will feel a little too much, but play along. Once you get a hang of it, it will become easy. Mark a row that does not have an assignment. In the marked row, mark a column that has a 0. In the marked column, mark a row that has an assignment. What after this? Well, after this, repeat 2 and 3 till no further marking is possible. mark a row that does not have an assignment. In the marked row, mark a column that has a 0. In the marked column, mark a row that has an assignment. After that, so after you have marked a row, you go back and in the marked row you mark a column. In the marked column you mark a row. In the marked row you mark a column. In the marked column you mark a row. Again, I understand this must be feeling very vague right now. Just play along with it. Come back to the question that we were doing. Well, this is the question that we were doing. Yes. What are we doing? We are drawing lines. Am I right? Just 1 second. Okay. We are drawing lines. So before we draw lines, we are going to do a little bit of a marking. Okay. Let me unzoom a little so that this fits on one page. How are we going to do that? With a pencil. Mark a row that does not have an assignment. Start identifying your rows that does not have an assignment. Row number 1 has an assignment. Row number 2 has an assignment. Row number 3 has an assignment. Row number 4 does not have an assignment. Then mark it. Mark a row that does not have an assignment. If you want, I'll do this with a sketch pen. Has an assignment, has an assignment, has an assignment, does not have an assignment. Mark a row that does not have an assignment. In the marked row, in the marked row, in the marked row, the row that you just marked, in the marked row, mark a column that has a 0. In the marked row, is there a 0? Yes, this is a 0. Then mark that column. In the marked row, mark a column that has a 0. Well, here there is a 0. In the marked column, this is the column you just marked. In the marked column, mark a row that has an assignment. In the marked column, mark a row that has an assignment. Is there an assignment? Yes, here there is an assignment. Then mark that row. Now do what? Well, go back to step 2. Okay. So after this, go back to 2 and do what? In the marked row. Okay, I just marked a row. Mark a column that has a 0. Well, there is no 0 left here. There is only one assignment. There is no cancelled 0. If there is no cancelled 0, that's it. These are your lines. And like I said, I understand and I realize this is a little cumbersome, and that is why I am going to repeat this for you. Let me quickly write this down. A, B, C, D, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. A, B, C, D, E. Correct? Yes. 22033. 22033. B will be 91470. 91470. C will be 06302. 06302. 80011. 80011. 85051. 85051. Correct? Yes. What are we going? we are going to start assigning first. Let's start. Exactly 1 0, mark it as an assignment, cancel every other 0 in that column. Exactly 1 0, mark it as an assignment, cancel every other 0 in that column. 2 zeros cannot be touched. Done. Exactly 1 0, mark it as an assignment, cancel everything else in that column. Nothing to cancel. Let's go column wise. Exactly 1 0, yes, mark it as an assignment, cancel every 0 in that row. Cancel. I just realized that I only got 4 assignments, which I got here also, the exact 4 assignments, when I should have gotten 5 assignments, which means optimal assignment is not reached. If optimal assignment is not reached, I have to redesign this matrix by drawing minimum number of lines. Why are we drawing the lines? To cover up the zeros. How are we going to draw the lines? Well, for now we didn't even go talk about drawing the lines. We are just making some random weird markings. I agree. Play along with me. Let's go back. Okay, I think this fits. Mark a row that does not have an assignment. Okay, row number 1 has an assignment, row number 2 has an assignment, row number 3 has an assignment, row number 4 does not have an assignment. Mark it. In the marked row, in the marked row, in the marked row, mark a column that has a 0. In the marked row, mark a column that has a 0. See, obviously, when I was doing row and column reduction, I made sure every row and every column has at least one 0. Now that 0 got cancelled out. So it might not have an assignment, but it will definitely have a 0. So, in the marked row, mark a column that has a 0. Where is the 0? Well, this is the 0. Mark that column then. Fine. In the marked column, oh, this is the column I just marked. Mark a row. In the marked column, mark a row. Okay, in this marked column, I have to mark one of these rows. But which one? The row that has an assignment. Well, in this column, can I say here there is an assignment? You want me to mark that row? Fantastic. Now what? Well, now keep repeating 2 and 3 till you don't get a answer. So, you have just marked a row with an assignment. Then in the marked row, mark a column with a 0. In the marked column, mark a row with an assignment. In the marked row, mark a column with a 0. In the marked column, mark a row with an assignment. Keep repeating till you can't stop. Okay. In the marked row, mark a column that has a 0. In the marked row, mark a column that has a 0. Well, in this row, there is no 0. Then can I say you are done with the marking? Yes. This is it. What after this? Once the marking is done, we now come to step 5 where we actually draw the lines. How do we do that? Draw lines through unmarked rows and marked columns. What do you do? Once you have done the marking, start drawing lines through unmarked rows and marked columns. So if you look at the rows, this one is unmarked, this one is unmarked, and this one is unmarked. So let me draw lines through these unmarked rows. And marked columns. There is just one marked column. Fantastic. Draw a line there. You are done. You have drawn the required number of lines. I'm going to say, I understand that this must be feeling a little cumbersome. But once you get into the flow of it, it is not very difficult. So I'm going to draw the matrix one more time, and I'm going to do the entire process one last time. I'm going to do a lot of questions where this is going to repeat now. And now I'm not going to give you a question where this is not going to happen. You will never get an assignment in the first go. You will have to draw lines and do this. But there is still another process after this. So let me first copy the matrix as and how it is, and again draw lines for you. Quickly, I started assigning. Okay? So 1 0 mark it, every other 0 cancel. 1 0 mark it, every other 0 cancel. 2 zeros don't touch. Can't, done already. 1 0 mark it, every column 0 cancel. You are done column wise, row wise, do column wise. 1 0 mark it, cancel every other 0. I realized that all zeros are exhausted, but I didn't get the minimum number of required assignments. If I didn't get the minimum number of required assignments, then what I will have to now do is that I will have to draw minimum number of lines. Now technically I draw a new matrix, but we've already drawn this before, so I'm going to do this in this itself. Step 1. Mark a row that does not have an assignment. Has an assignment, has an assignment, has an assignment, does not have an assignment. In the marked row, mark a column that has a 0. In this marked row, can I say here there is a 0? So this column has a 0. In the marked column, mark a row that has an assignment. Well, in this column, this right here is the assignment. So I have to mark this row. In the marked row, mark a column that has a 0. There is no more 0. So we stop here. Draw lines through unmarked rows. What are the unmarked rows? Unmarked row number 1, unmarked row number 2, and unmarked row number 3, and marked columns. This is the only one marked column. And now I want to tell you something. Remember I told you that you are drawing lines to cover up all the zeros. So the first thing that you are going to check is, are all your zeros covered? Because if all your zeros are not covered, there was no point in doing this. As in, the entire point of doing this is so that all the zeros are covered. If you couldn't cover zeros, there was no point in doing this. If you check, all the zeros are under the lines. Fantastic. Check number 2. Remember I told you, you have to do this with minimum number of lines. Well, who decides what the minimum is? I'll tell you. How many assignments did you get? 4. Well, you were supposed to get 5, you didn't get it. You got only 4. Then you should have covered all zeros in 4 lines. Check. 1, 2, 3, 4. That's it. So if you got only 4 assignments, in 4 lines, you should cover up all zeros. And now we move on to this next step, and that is making this matrix better. How? We are now moving on to the changing of the matrix. You will see 3 types of numbers in that marking. And what is the 3 types of numbers? Well, there are numbers from which the line is passing once. So here this 0, this 5, the line is passing once. If you look at the 6, there are 2 lines passing, or it is also called as a junction element. This is the second kind of an element. And the third and the last is uncovered elements, where does not have any line. So 3 types of elements. Elements that have 0 lines on them or no lines on them. Elements that have 1 line on them, and elements that have 2 lines on them. Identify that first. Identify your 3 elements. And that is what are the 3? Uncovered, single line covered, and the last is double line covered, also known as junction elements. So there are 3 types. Ones that are not covered at all, ones that are covered with a single line, and ones that are covered with a double line. So they form a junction. Okay. What next? Choose the smallest from the uncovered elements. What to do? From the uncovered, choose the smallest. Subtract it from the uncovered. So choose the smallest from the uncovered, subtract it from all the uncovered. Number 4, add it to the junction elements. And number 5, which technically does not need to be written, or they never write it, but I want to tell you this because I want you to remember this. Leave the single line covered untouched, or leave the single covered unchanged, or leave the single covered alone. So once you've drawn the lines, you will identify 3 kinds of elements in your lines. Number 1, uncovered, single line covered, and junction elements. After that, choose the smallest from the uncovered elements, subtract it from the uncovered, add it to the junction elements, and leave the single covered untouched. So let's see what we are going to do. This is my question. Is that right? 3 types of question, 3 types of values: single covered, junction, and uncovered. Choose the smallest from the uncovered, so the uncovered elements are 2, 9, 8, 8, 3, 7, 11, 5. What is the smallest? Well, the smallest is 2. This 2 will be subtracted from these uncovered elements. It will be added to the junction elements, and the single covered will remain untouched. A, B, C, D, E, 1, 2, 3, 4, and 5. 2 uncovered minus 2 is 0. 9 minus 2 is 7. This 0 is single covered. Single covered have to be untouched. 0. Uncovered, subtract. Uncovered, subtract. 2 is single covered, untouched. 1 is single covered, untouched. 6 is at the junction. 6 plus 2 will become 8. 0 single covered untouched, 5 single covered untouched. 0 single covered untouched, 4 single covered untouched, 3 junction. At the junction I add 3 plus 2 is 5. 0 single covered untouched, 0 single covered untouched. Let's come to the next. 3 uncovered subtract, 7 uncovered subtract, 0 single covered untouched, 11 uncovered subtract, 5 uncovered subtract. 3 single covered untouched, 0 single covered untouched, 2 junction will become 5. 1 remains untouched, 1 remains untouched. Sorry, 2 plus 2 will become 4. Done? You have, congratulations, you have successfully revised the matrix. Now what? Go back. Step 1 row reduction, step 2 column reduction, step 3 assignment. If you get 5 assignments, look up, thank your stars, say thank you God. If you didn't get it, mark a row that does not have an assignment. In the marked row, mark a column that has a 0. In the marked column, mark a row that has an assignment. Keep doing this till the marking is stopped. Draw lines through unmarked rows and marked columns. Pick up the smallest from the uncovered, subtract it from the uncovered, add it to the junction, leave the single covered alone. You will get a new matrix. Again, do an assignment. If you get an assignment, fantastic. If you don't, step 1 row reduction, step 2 column reduction, step 3 assignment. You will keep doing this till you have not reached the best or you have not reached an optimal assignment. More often than always, a row and a column reduction is not required after this because there are already enough number of zeros. But to be sure, just make sure you check once. Yes, 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 and yes. Yes, 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 and yes. So every row and column already has a 0. Fine then. You can start assignment. I have lost track of what step I am on because I am doing an explanation of everything and doing everything 2 or 3 times. So this one I am going to write without a step, and you could do it in the same table, but I want to draw a new table so that if at all I make a mistake, I just have to go back to the old table, copy it, and then continue the question. Let's start. 2 assignments, 2 zeros, can't do anything. Move to the next step. 3 zeros, sorry, 1 0, perfect. Mark it as an assignment, cancel every 0 in that column. 2 zeros, can't do anything. 1 single 0, mark it as an assignment, cancel every 0 in that column. 1 0, mark it as an assignment, cancel every 0 in that column. You are done row wise, start column wise. 2 zeros can't do anything. 1 0 already marked. 2 zeros already marked or cancelled. 1 0 already marked. 2 zeros already marked or cancelled. 1 0, mark it as an assignment, cancel every 0 in that row. You are done column wise, again start row wise. Row wise 1 0, mark it as an assignment, cancel every 0 in that column, done. How many assignments did you get? 5. Look up to God, thank your stars, and this is your answer. And the answer is 1, 2, 3, 4, 5. 1 goes to A, 2 goes to D, 3 goes to E, 4 goes to C, 5 goes to B. Now, where is my original question? Is also a very good question. Yes, I got it. 1 goes to A. 1 goes to A, the answer is 6. Okay. 2 goes to D. 2 goes to D is 0. Okay. 3 goes to E. 3 goes to E is 6. Sorry. 3 goes to E is 6. Fantastic. 4 goes to C. 4 goes to C is 2. And lastly 5 goes to B. 5 goes to B is 0. So the total minimum that I require is 6 plus 6 is 12 plus 2 is 14. I'm quickly going to do a recap, after which we are going to move into the next question. This was the question given to me. The objective was to minimize, hence no change of objective required. The problem was balanced, so no requirement of balancing. And the third and the last, there was no prohibition. So I said fantastic. Step 1 row reduction, step 2 column reduction, step 3 assignment. I made an assignment, but I was supposed to get 5 assignments. I only got 4, which means optimal assignment is not reached. If optimal assignment is not reached, we say that since number of assignments is not equal to the number of rows and the number of columns, optimal assignment is not reached. We redesign the reduced matrix by drawing lines. How do you draw lines? Mark a row that does not have an assignment. In the marked row, mark a column that has a 0. In the marked column, mark a row that has an assignment. In the marked row, mark a column that has a 0. But this row does not have a 0 anywhere, so we stop right there. After doing that, where do you draw lines? You draw lines through unmarked rows and marked columns. These were your unmarked rows, these were your marked rows, so the remaining were unmarked. And marked column, this was the marked column. After doing that, you pick the smallest from the uncovered, subtract it from the uncovered, add it to the junction, and leave the singly covered elements alone. After doing that, you have your redesigned matrix or your new matrix. Now what do you do? Row reduction, column reduction, assignment. Most of the times row and column reduction is not required, but just to be sure, check if row and column reduction is required. If required, do it. If not required, don't. Step 1 row reduction, step 2 column reduction, not required, assignment. When I do the assignment this time, I get 5 assignments. You thank your stars and you write down your final answer. If you've understood this, then this is it. Now I'm not lying anymore. This is it. This is how you solve an assignment problem. So this is it then. This is everything that you need to know about an assignment problem. What I'm going to do is I'm going to stop this session here. And we meet in the next session. And obviously, like I said, I'm going to do quite a few questions. The sheet still has 3 more questions. So I'm going to do those 3 questions and then we'll see what the institute material has to offer. So thank you very much. I will see you in the next session.